Hello guys, today we're going to finish the second part of 4.4 logarithmic equations. So what is the logarithmic equation? So here we have two examples. Basically what they're saying is a logarithmic equation just an equation contains a variable in the logarithm expression. Okay? Alright, let's go ahead and look at example 6. Example 6 we have part A, log base 4 of x plus 3 equals 2. So we need to solve these logarithm equations. So let's look at the right hand side really quick. So we're going to see how we solve this type of question. So step 1, we're going to express the equation in the form log base b of m equal to c. So if you look at this, if I'm going to color this really quick. So here we have m. Alright, so anything inside here, that will be our m. And then we have a c right here. Right, c is just some constant in this case, and then when our base is just going to be 4. So in this case, because the form is the log base b, m equals c form, so we're going to skip the step 1. And then we look at step 2, we're going to use the definition of a logarithm to rewrite the equation in exponential form. So all we're doing is, remember we did it last time, we did this snail, so we're going to do like this. Right, so here we're going to write 4 to the second power equal to m. We said m is x plus 3. That is our step 2. So then we'll just have to step 3 to solve for variable. In this case, we're going to have 16 equal to x plus 3, which our x just equal to 13. Okay, so that is step 3. And then if you look at this step 4, you have to check your solution. Okay, so this is very important. Normally checking solution is optional, but in this case you must check solutions. Okay, we're going to check if at least you have to check if m is greater than 0. If this is not the case, that is not your solution. Alright, so let's go ahead and try to check the answer. Okay, so we're going to have log base 4. We said our x is 13. We're just going to replace with x and then check is it give you 2. So important part is our m, right? So we said at least check this piece. Is it this is greater than 0? The answer is yes, 16 is greater than 0. So anyway, at least you have to check this. But if you want to do a little bit further, you can write log base 4 of 16 is equal to 2. You have to think 4 to the what power give you 16, which is 2. So that means you check the answer, which is correct. Okay, that is how you solve this type of question. Remember, number 4 is important. We said because we must check if m is greater than 0. Okay, all right, let's go ahead and look at part B. So part B, we have 3 natural log of 2x equal to 12. We do want to get rid of the 3 because that's from your natural log, right? So we're going to get rid of this by dividing 3 both sides. So this is going to be canceled. So we're going to have natural log 2x equal to 4. Natural log just actually is a log. Our base is e. Okay, if you forgot, make sure you remember that. So natural log basically just a log base e. That is our step 1, right? All right, remember the snail. So we're going to have e to the 4th power equal to 2x. If I have a 2x equals e to the 4th power, so you just have to divide by 2 both sides. X equal to e to the 4th power over 2. Again, if they want you to round it, so you just plug this inside your calculator and then you round it. So that is our step 3. So step 4, again, this is very important. We're going to check if m is greater than 0. So let's go back and see. We're going to plug this whole thing inside sub back. So we're going to check. We're going to have a 3 natural log 2 times e to the 4th power over 2. It's going to give you 12. So you're going to have 3 natural log. This is going to be canceled, and then e to the 4th power. And then you're going to check it. It's going to give you 12. Now you look, what is our m in this case? You have to realize that this is your m. Okay? What is the e to the 4th power? E just going to be 2.7. 2.7 to the 4th power is just going to be a positive number, right? So that means actually this satisfies m is greater than 0. If you want to stop here, that's fine. But if you want to continue to check your answer, so anytime we see natural log and e, if they're together, they're just going to cancel out. So you're going to have 3 times 4, which is give you 12, right? So check mark. Again, you got it correct. Example 7. Here we have log base 2 x plus log base 2 x minus 7 equals 3. Recall, we want to do is we want to turn this into the form log base b m equal to c. So if you look at this, you have to recall anytime we have the same base, right? And then if I have a plus, or use this color, if we have a plus, that means you can actually use the product rule. We learned this in previous session. So now we look at this, that will be log base 2, we're going to have x multiply x minus 7 equal to 3. And then now we actually turn this into the form log base b m equals c form, right? So even though it looks complicated, so we can actually do this, all right? Our m, just this whole thing is our m, right? And then here is my c, and then my base is a 2. All right, so which means now I can use this. Okay, you can simplify this. If you want to do distribution first, that's fine. It doesn't really matter. Okay, so we're going to have a 2 to the third power equal to this whole thing, x multiply x minus 7. Right, so that is the part right here. So we have to recall we did this b to the c power give you m. Okay, now we're just going to simplify. We're going to have a equal to x squared and minus 7x. Okay, and then we're going to have x squared minus 7x. I'm going to subtract 8 both sides. That will be subtract 8. And then I can write this equal to 0 on the left side, but I want to write the right hand side because I'm used to it. Okay, so now I'm going to turn this into a quadratic equation. You have been solving quadratic equation for a long time. Okay, so we always can try a different method. So in this case, the easiest way probably just going to use factor, right? So that will be x minus 8 and x plus 1 equals 0. And then you're going to have x equals 8, or you're going to have x equal to negative 1. So we have 2 answers until here. And then remember, we must check our answer. Okay, so if I'm going to check x equals 8, okay, where I'm going to bring this back to the original equation, that will be log base 2. Our x is just going to be 8, and then plus log base 2. Again, our x is just going to be 8 minus 7. We're going to check, is it going to give you 3? Again, if you want to check this until the end, that's fine, but at least you have to check if the m is greater than 0 or not. Okay, so in this case, our m, this piece 8, that means greater than 0. We also look at 8 minus 7 is a positive, greater than 0. So this actually is fine, right? Satisfy the m greater than 0 condition. If you want to continue, you can do this. 2 to the what power give you 8, that is 3. And then we're going to have 2 to the what power give you 1, that different, that is 0. So that means this is a left side and a right side is check mark. So we got this correct. Also, we got to check x equal negative 1. Log base 2 and then negative 1. Okay, we just did the substitution. So now we're going to look log base 2 negative 1. So this means our m is less than 0, and the negative 1, negative 7, that also give us m is less than 0, which means this is not our solution. The only solution we have is x equal to 8. That is the reason why it's so important to check your answer, because if m is less than 0, then that is not your solution. Okay? Let's go ahead and work on example 8. Example 8 is solving a logarithm equation. So we have another one here. Now we're dealing with natural log, and then you have to look. So here we have a subtract, and then we have learned if we have a subtract, we're going to use a quotient rule. So now we're going to turn this into natural log. Our m in this case is actually just going to be x plus 2 over 4x plus 3. And then we have on the right hand side, we're going to have natural log 1 over x. If you look at this, we have natural log on the left side and natural log on the right side. They're equal to each other. That implies the inside must be equal to each other, right? That will be x plus 2 over 4x plus 3. That must be equivalent to 1 over x. We're just going to do a cross multiply. This is the things we have learned in the past. Okay, so now we're doing distribution. And then now we're going to have x squared, and then we're going to move everything to the left side. That will be negative 2x, and then negative 3, and then equals to 0. You can take your time. Now we can factor it, and then we can simplify it. Then we're going to have x equals 3, or we're going to have x equal negative 1. Always remember this type of question. You must check the answer if m greater than 0. Okay, I have a 3 right here. If I'm going to bring it back to my original equation, that would be natural log 3 plus 2. Okay, check mark because this is m greater than 0. And then minus natural log, right? 4x plus 3. Okay, 12 plus 3, that's a 15. That definitely give me a positive number. This also check mark. And then equal to natural log 1 over 3. Okay, that is also a positive number. If you want to finish checking the answer, that's fine. Or you can just move on if you run out of time. You can plug this inside your calculator and then check your final answer. And maybe I'll just do it really quick. And then we'll have natural log 5 minus natural log 15. And then it's going to give you natural log 1 over 3. And then you look at this again. If it's a minus, that means I can use the quotient rule. That is 5 over 15. That's 1 over 3. So that's the reason why you can. Let's go ahead and look at what happens if I have x equal to negative 1. You can bring this back, okay? You can, or just doing visually. So you're going to have natural log negative 1 plus 2 minus natural log negative, this is 4 multiplied negative 1 and plus 3. And then you also check if it's a natural log 1 over negative 1. You look at any of them. If let's just look at this piece, 1 over negative 1, that's definitely less than 0. That immediately tells you this is not the solution. So which means our x equals 3 is your solution. Be careful on this type of question. Alcohol and the risk of a car accident. You can pause it and then read the question. All they're saying is, I gave you a model. Okay, this is given to you. R equal to 6 e to the 12.77x. You have to know what is our x and then what is our r. The important part I'm going to read. X tells you is a blood alcohol concentration. Okay, that is our x right there. And the r is given percent. So r is given as a percent, is the risk. Okay, that is, we say r. That's the risk. And then they're asking what's the blood alcohol concentration, which you're asking what is x when we have 17% risk of a car accident. That means your r is 17. And then now we can just plug in 6e to the 12.77x power. We have a leading coefficient right here on the right hand side, right, for the variable. Divide by 6 on both sides, and they're going to cancel out. We're going to have e to the 12.77x. We'll just move this from the right to the left, and then equal to 17 over 6. Now we turn this to a exponential equation. Our base in this case is e. Is not 10. When we have a base is not 10, we said we have to take a natural log of both sides. So what happens is we have natural log, we have e. We said this piece is going to cancel out. So we're going to have a 12.77x equal to natural log 17 over 6. You still got to remember we're solving for x. Okay, natural log 17 over 6 is just some constant. So now we're going to divide by 12.77 both sides. and then my x, this is going to be canceled. That will be natural log 17 over 6 over 12.77. So if they want you to round this to 2 decimal, you just plug this whole thing inside your calculator. You're going to get around 0.08. Okay, so that is how you solve this question. Example 10, revisiting the formula for compound interest. So we have learned this before. So let's see. A equal to P multiplied 1 plus R over N to the N multiplied T power. So if you look at the first sentence until here, I'm just going to highlight this really quick for you. So until here, this is the whole thing. It just explain what this formula means. If you remember, you can really skip that part, okay? Basically, they ask you, how long will it take 25,000 to grow to 500,000 at 9% annual interest, compounded monthly? Okay, so compounded monthly, right away, you should know our N is equal to 12. So A is the amount in the end, and then P is initial investment. So now let's plug it in everything. All right, so we said in the end, we grow this into 500,000. The initial amount was 25,000. And then we have multiplied 1 plus, we said that R is just the interest rate. Interest rate is 9%. I'm going to turn this into 0.09 over, and it's 12. And then we have 12 multiplied T is the years. So in this case, they want to ask you what is T, right? Because how long will it take this whole thing? Basically double amount. Once you set this up, okay, you should realize 500,000 equal to 25,000 and then multiply this whole thing, right? If I divide 25,000 both sides, that would be 2 equal to this whole thing will be canceled. We're going to have 1 plus 0.09 over 12 and to the power 12t. So let's clean up this a little bit. So we're going to have 2 equal to 1 plus 0.09 over 12. Just going to give you around 1.0075 to the 12t. Okay, because I'm used to the variable on the left side and the constant on the right hand side, I'm going to write this as 1.0075 to 12t equal to 2. Now we turn this into an exponential equation. So we said if we have an exponential equation, the base is now 10, where you take a natural log both sides. And then you look, we have a natural log, we have a variable in the exponents. That means we have to apply the power rule. So that will give us 12t natural log 1.0075 equal to natural log 2. So now you have to focus. What is my variable? Okay, don't get lost. My variable is t, right? That means everything else is just some constant. In the past, you have learned something like this. If I have a 12x multiply this, let's say 360, and then equal to 480. I'm just making some examples, right? You could just divide this both sides. And then what happens here, they're going to be canceled. And then you have x left, right? So it's the same concept here. So now all we have to do is to divide by 12 natural log 1.0075. And then here we also do the same thing, 12 natural log 1.0075. Now where this is going to cancel out, this piece is going to be canceled out as well. So all you have left is t equal to natural log 2 over 12 natural log 1.0075. So in this way, you're just going to round it to 1 decimal. So that is 33.4 years. That finished our 4.4. Thank you very much for watching the lesson, and I'll see you guys next time.